be looking at characteristics of functions. And the first part we want to look at is the long run and the local behavior of functions. So we've looked at many different graphs over this course, and we've looked at parent functions and the way that they behave. So what we're going to do is we're going to now look at some characteristics of polynomial functions and also look at their end behavior. So the first thing we want to look at is what is defined as an increasing function. Well, an increasing function is as x increases, the y's are increasing. And what's happening is basically when you move from left to right, the function is going upward. So we're looking at this piece right here. We can see that it's increasing. And then as the x's are increasing or moving to the right, these y values are also increasing. And so in this example, if I wanted to say what are the intervals on which this function is increasing, we can see that there's an arrow here and here. So we would go from negative infinity. Now right here is where that increasing stops. So we would say comma -2. We always use parentheses on the increasing, decreasing functions because exactly at -2, it's doing neither. Union with, and then we start increasing again here at +2 to positive infinity. So in this example, that would be the interval on which this function is increasing. Also, we could look at where is the function decreasing. We say it's decreasing when as x increases, again, moving from left to right, your y decreases. So we always move left to right, just like you read a book. And so where's this function decreasing? It would be right here in the middle. We can see that it's going downward. And so the interval on which it's decreasing would be from -2 to +2. And so again, in this example, you can see we have all of our bases covered. We have where it's increasing and decreasing. We're always going to use parentheses, and also make note that in these intervals, these are x values that we are notating. Other things that we can pull from this. When you're looking at, and some of you on increasing, decreasing, let's just emphasize that these are going to be x values in interval notation. The next part we're going to look at are what are the local or relative extrema. Now with your increasing and decreasing, you're looking at x values. With your local and relative extrema, you're going to be looking at a y value. For the maximum, this is when you change from increasing to decreasing. And where does it happen that we changed from increasing to decreasing? So we were going up here, and then we changed to going down. And so right here at this point, this would be our local max. And it occurs at the point -2, 16. Now with your minimum, this is the reverse of this. So we would say this is when you change from decreasing to increasing. So you can see we're decreasing down here, and then we change to increasing. So right here at this point, this is +2, -16. This is where you would have a local minimum or a minimum value. And so they say, what is the maximum value? The maximum value is at 16 or f of 2. And they'll say, what is the minimum value? It's -16, and that occurred at f of -2. And so as you're working through this section here with your increasing, decreasing, remember it's your x values in interval notation. And when you're looking at what is the maximum value, that's a y value. Or what is the minimum value, that's again a y value. Now those are just local, talking about, okay, this one is the highest in this area. This is the lowest in this area. Let's look at absolute extrema. When we're looking at the absolute extrema, I want to emphasize here that this is going to occur when you're on a closed interval. That means we're not going off into the affinities. So you can see in this example over here, I have exact ending points. I don't have arrows on the end. And when you're looking for the maximum, absolute maximum value, it is the max value in the entire function. If we look back on this previous one, you can see that we did have a max value here, but then over here when this arrow went higher, it went even higher than that, and that's why we called it a local. The same is true on this minimum. This is a minimum value where it changed from decreasing to increasing, but because of this arrow over here, this line would continue on. So this is just a local in its area minimum. And so with absolute, when you are looking at the absolute extreme and you're looking for the maximum value of all the values that you have. And so in this case, it would occur right here. This is the highest point. And so we would say, okay, the max value is 2, and that occurs at f of 2. What is the minimum value? And we're looking for the minimum value, the smallest value of all the values. And we can see that this occurs right here. This is the lowest point. So that means the minimum value is at -2, and that occurs at f of 0. So again, with the absolute maximum minimums, this is going to happen on your closed interval because it does not have the arrows that are going off into the infinities. So let's kind of take these definitions and let's just do quite a few examples to go with this. So in the first one, it says, analyze the following graphs. So here's what I want to do. In this one, I want to figure out the intervals on where it's increasing and the intervals on which it's decreasing. I want to find the local minimum and I want to find the local maximum. So where is it increasing? Okay, so let's look at that. We'll use a little highlighter to help us with that. It's increasing right here, and then it's increasing again here. We can look at where is it decreasing. You can see the graph is going down here, and then again going down here kind of just slightly. And so when I'm looking at where is it increasing, I'm going to look at the x values. So it's increasing from 1 to about 3, union with from 4 to positive infinity. And then when I go over here and I say, okay, well, let's look at decreasing. Remember, decreasing was that highlighted a pink. And so I would say, okay, where is it decreasing? It's decreasing from -infinity to 1, union with 3 to 4. Now, where does the local minimum occur? So your minimum is going to happen when it goes from pink to blue. So that would be here. And then we also have another one here. So we would say that we have a local minimum of -1 at x equal to 1, or if you like, f of 1 equal to -1. And we're going to have another one at, we'll estimate here, of 1/2 at x equal to 4. Then you're also going to have a local max. So let's look for the max. Max is when it goes from blue to pink, or when it goes from increasing to decreasing. And we only have that right here. These are just local, not absolute. So we're going to have a local max of 1 at x, of 1 at x equal to 3. Thought I was going to have myself. Or we could say f of 3 is equal to 1. Over here, we would say that this was f of 4 equal to 1/2. And again, I was just estimating about where that was. Okay, let's look at another example. Okay, same thing we want to do with these next two examples. So I'm just going to kind of jot down what we want to do. I want to look for increasing and decreasing, and then I'm going to look for any local extremas. So where is it increasing? And we'll just stick with our same colorings here. So increasing is going to be our highlighted blue, and it's increasing right here on this interval, and then it's decreasing here. And so we need to jot that down. So it's increasing from -1 to +1. Again, we're taking x values. Where is it decreasing? That would be -infinity to -1, union with 1 to positive infinity. Now let's just mark down our local minimum and maximums on the graph itself. So right here, we would have a local min, and that occurs at -1, -2. Right here, we would have a local max, and that occurs at 1, 2. Now this next one is a little bit different. And these last two, we had arrows here on the end. So that's why we were going from negative infinities to positive infinities. And this next one, what I want to do is notice that this is on a closed interval. So on the closed interval, you can see that we have ending points. These are not arrows. So first let's start with our increasing and decreasing, and then we'll talk about those extrema. So where is it increasing? I'll continue highlighting. So it's increasing this little spurt right here, and then right here. Where is it decreasing? Here's our decreasing. Here's our decreasing. Some say, okay, it's increasing. Now we're going to have to estimate because this is kind of in the middle here. So I'll say it's increasing from negative 2.5 to 2, union with 0 to positive 2. Excuse me, I left off that negative right there. Then where is it decreasing? It's decreasing from negative 2 to 0, union with 2 to positive 3. Now let's talk mins and maxes. So we would say right here, when it went from that blue to pink, so increasing and decreasing, this is your local max, and this occurs at negative 216. We would also say that this is a local max, and it occurred at positive 216. We have a minimum here. This would be considered your local minimum, and this occurred at 0, 0. And then we would say this is a local minimum. See how low it went? And it occurred at, let's see, 3, negative 10. And then once you identify all your minimums and maximums, that's when on this closed interval, you could come back in and you could say, okay, where are my absolutes? Well, this has an absolute minimum at 3, negative 10. So it can be called a local, very generic minimum, but it's also the absolute minimum of the entire graph. And because this has two values up here, this has no absolute max. So I just want to kind of show you the differences between the open intervals with the arrows and then the closed intervals.